and welcome to another episode of FooBar. In today's video, I want to show you how you can load test your serverless applications from a Lambda function using artillery. This code that I will be showing today and the whole application we are going to be working on is part of a series of videos. I will talk more about that in the end, but just for you to bear in mind, we are going to be working with an existing application. But let's start talking about what is artillery. So artillery is a testing library, and basically it helps you to make your application scale, to be performant, to be resilient over high load in general. That's one of the main features of artillery. I've been using artillery for, many years, and I've been using them a lot for different applications. And there's kind of two big reasons why I will use artillery. The first one, I think the obvious one, is to do load testing. Artillery is a great tool to do load testing in your applications. And the second one that I like to do is to do CI/CD testing. Basically that I can test that my application works. So I can run some scenarios and I can make sure that the system behaves as expected. And these are two different ways of using artillery. But in this video, we are focusing on load testing. So load testing for serverless applications is very, very important. You are familiar with serverless, you might think, but everything scales automatically, and yes, no. So a lot of the services do scale automatically, but the problem is that when we combine multiple services together, sometimes these services have different ways of scaling. Some services might scale more, some servers might need to get configured to be able to scale more. And if you're using third parties, then everything becomes more complex because sometimes there's tiers and there is things that happen that are throttling your request. So those things are happening quite commonly with serverless applications. And as a developer, you need to be aware of what are the limits of your applications. Even though our applications can scale and we don't need to scale them, we need to understand what are the limits. And if the limits are not the right ones for our traffic that we are expecting, then we need to talk to support and increase those limits, like in the case of AWS, or we need to refactor the application in order to be able to go through those limits, or we might need to, if we are working with a third party, maybe change the tier that we are working in so we get more connections or whatever we are working with them. So that's one of the main reasons why you want to do load testing. I remember when I was doing development million years ago, my previous job that we were running serverless environments, I remember I got a call from the technical account manager from AWS. I was a customer by them because we were doing so many calls to Amazon Cognito. So basically we discovered Cognito and we were like, will this scale? Will this work? And then we were bombarding that thing with requests and making sure that it will work for our use case, because we had by that time a platform that received a lot of requests, and we want to make sure that the services that we were putting in our platform were according to the scale that our platform would need. Another thing that you can do with load test is that you can get an idea of how much your serverless application will cost. This is not like an official way of understanding cost, but this will help you to get a ballpark idea. So this is something also I have done in my customer experience, that after I tweak the whole service to have the right levels, everything is right and everything is shiny, and now I grab the expected load or the average load or the maximum load, and I will load test it for a while, and I will try to understand the spending of during that period of time. So if we run it for 3 or 4 hours, then I can understand how many Lambda calls we're doing, how many minutes it was running, how many other services were called, how many of this and that, and then I can have an idea on how much my service will cost, because it's kind of hard sometimes. But the video is not about that. The video is about load testing serverless applications. So until not very recent, and actually I think it's still a preview. This is what I'm going to show you. And for you that you're not aware, there is a Twitter community where this particular launch was pre-announced. And in this Twitter community, we talk all about serverless. I'll leave you the link in the description box. And in this Twitter community, somebody from Artillery came and shared with us that they are going to launch a new feature, and this feature allows you to run Artillery test in Lambda. And until that time, that it was in the middle of the summer, basically load testing with Artillery was only possible either in your local machine or in a virtual server. And I think it was the only reason I turned an EC2 machine in the last million years just to run my Artillery test. Because if you try to run those from your local machine, you will kill your computer, unless you're just running some simple tests. But if you really want to make sure that you are loading your system, you need to run a heavy test, and that is not very good from your machine. But from a nice EC2, you can do those things. So in this video, I want to show you more about that. I want to show you how you can load test an application, how to write one of these tests, how to run this test in Lambda, and we are going to see an application explode in our face when scale doesn't work really well. But let's get started. So the first thing we want to do, and I will leave you the documentation for Artillery for this particular feature in the description box, is that you make sure that you have the latest Artillery. So I think this is supported from, let me check, version 2.0.0.21 or later. So that is something that that you need to have in order for this to work. Then you need to configure your AWS credentials as if you will be configuring your AWS CLI. So if you have that already configured, then you're good, because that will use your default profile. So make sure that you have the profile with the right credentials, and then you can run the test. If you have any problems, for example, with your IAM roles, there is in the documentation the role that that you need to assign the user that is running this, basically your CLI, your computer that you have in that machine that you have the credentials for. It needs to have enough permissions to run all those things that are in the documentation of Artillery. So all that is linked just in case you have any trouble. And then you're able to run the test in the computer. So we are going to get there in a second. A couple of limitations. First one, this is in preview for the time I'm making this video. Maybe if you're watching in the future, this already got out of preview, so just make sure that you check that. And then the second limitation is the 15-minute time that Lambda runs. The test cannot go over that time. So yeah, that's something you have to have in mind. Also, you cannot turn off the test. So when you are like killing the terminal, that doesn't mean that the test is stopping. The test is running in the Lambda, so basically you need to delete the Lambda in order for the test to stop. So those are things you have in mind. But in general, you can manufacture your test to be under 15 minutes. And if you're working in a serverless architecture, 15 minutes is more than enough. But yeah, so those are limitations. So let's go now to the code and see what we have here. So I mentioned that this code that I'm going to test is part of a longer series of videos. So this is an e-commerce site that I built for, let me see if I can find the URL. So I mentioned that this is part of a series of videos where we are going to build an e-commerce. This is the e-commerce that we have migrated from on-premise to the serverless stack using Amplify, Lambda, and Mongo Atlas. So this is how it looks, but because we are going to use Artillery, we are really focusing on our backend. So we are focusing on testing this Lambda function. So this Lambda function is Lambda function that contains the Node application using the Lambda web adapter. So if you don't understand anything about this, check the playlist that is listed, but basically the Lambda web adapter allows me to grab a whole Node application into a Lambda function. So it's pretty magical. So we have the Lambda to host our Node application, Amplify to host the React, and the database is in Mongo Atlas. So now with Artillery, what we are going to test is the Lambda and the Mongo connection. So this is type of a load test of that type of integration test between these two services, and you will see how everything reacts. Also, For this demo, we have built a CloudWatch dashboard, and there is also a video on that on this playlist. So we will use that dashboard to understand what is going on. As well, we are going to use the dashboard from the Lambda function if we need so. So that's it. So if we are in the Mongo Atlas, we can also open the monitoring tool, because we will see this explode in a second. This Mongo Atlas cluster is hosted in the free tier of Mongo, so you have a certain level of connections, and this is important to have in mind. So now we have opened this, we have the connections here, and everything looks good. It's working. So let's go to the code, and here we are going to write our artillery tests. So what we have here is a very simple test. So let's go even to smaller test here. And this smaller test, what it does, it sends for 60 seconds, every second, one request. It sends a request to this target in this particular URL. This is a valid URL, this is a valid REST URL. What it do, it returns all the products, so we can open it in the Thunder client, for example. I think it's this one. Yes, and we can see that it returns all the products, so this is what it returns. But in this case, we are not caring about the return, we want to make sure what happens. In order to run this, what we need to do is to call artillery. And how we do that? Well, we will use artillery in Lambda. So I have done these scripts in a folder inside this repository that is called artillery. So we first going to get there. And oh, I wrong. I need to see the artillery, and then we are there where are my scripts. Then we can run that command. Then I pasted in too many lines and it's failing. So let's bring it in one line. So this is the command, artillery run, then the name of the script, and in this case it's going to be smaller script. And then the platform is AWS Lambda, and then the region where you want to run this. I will run this in Ireland. So I will press enter, and then this will start creating my Lambda function for artillery. This is something I have no idea what kind of things in that Lambda function, and it's just doing it for me. So what this does is create the Lambda function in my AWS account, so we should be able to see it, and it should be somewhere here soon. And then it will run the test for us, and it will show in the console some logs. And then when the test is done, it will destroy that function and all the resources around it. So let's get back when this is starting to run, because it takes a little while. Wait here. So now the tests are running. So you can see here, preparing the AWS. Here is the Lambda function. So we should be able to see it now. Here it is. We can see the account number. We can see that it started the warm up. There is only one phase. So we will see this for 1 minute. So it says there are 200 as a response 8. There are 8 requests, and there is 1 request per second, so that's good. And this is the response time, 95 milliseconds on minimum, 215 maximum, and 102 of average. And here we have the piece, so this is quite nice. We can see all of that for, I think, every 10 seconds or something like that. So it comes with a lot of information, and here we can see the end, and then we can go to our CloudWatch, and we should be able to see some metrics appearing. We can see that there were no errors, so that's good in our function. Everything was invoked correctly, and there were no concurrent executions. So everything is nice and good. We can see here our latency for the metrics are still appearing as this is. refreshing. We can see our latency for our URL and our duration. So everything looks good. So this is a very simple test that doesn't really harm the system. That's good. Then I have built this artillery script, and this one is a little bit more complex. We have more phases. So in here we have a warm-up phase that will for 1 minute send every second 5. Then we have a ramp-up that is for 1 minute. We'll have 5 until we get to 15 at the same time. And then we will have a sustained load of 15 requests per second for 2 minutes. In a serverless world, I don't think it does matter that much, this ramp up and things like that, because everything is running in its own. But let's see what happens. So here we are going to run again the same scenario. That is a very basic getting that that product. So we can do this, and we can change the script to artillery script, and then we can run it. Here we should see, I hope, something good still, but let's see. This will take a while again while it loads and gets everything ready. So I see you when the tests are running. So now the tests are starting to run. So it will run the first scenario, and the only one. It starts with the warm-up, and we can open the dashboard and see what is going on. So here we have, as I mentioned, the dashboard for the connections. This is important for Mongo. This will be the limit that, I don't want to spoil it, but well, let's see. It should be also automatically refreshing. So that's good. And here we have our CloudWatch metrics that are also automatic refreshing. The things we will care is about Lambda. The first part is about Amplify, but we don't care about that yet. So let's look at Lambda, and soon it will start appearing metrics. So we can see here that it started. So it's sending things now. Starting to send 50 requests basically, and we have a 5 requests per second. So we have got 50, and we have 50 still, and let's see what is going on. If everything is good, then it will resolve the request and keep on going. Now the warm-up ended and everything looked okay, no errors here, so that's good. Now we are going to start a ramp up. So ramping up is here. It also lasts for 1 minute, and we are going to get to from 5 requests per second to 15 requests per second. So that's ramping up. So you can see 5. Now we have 7. Have 9. So for now it's good because the response time is less than a second. So basically every time a new request comes in, the other requests have finished, so we are good. So no big deal here. So we are starting to see 13 requests per second. The amount of requests are increasing, but we are now still going. So this still works because we can see that this ends still in less time than the next requests are coming. So in less than a second, we launch 15 requests. Everything is good. 1 request, boom, boom, boom. So this is going to end in a good note, I already telling you, because we are not going to reach our limitations. Our connections are used well. So let this run and it will finish. And I already telling you this is good. Let's do a little bit more with our tests. So I have done here a scenario that is a little bit more cheeky, but I think it represents better what is the reality. So what I copied everything. So let's replace that with that. And this scenario, let's make sure that we have it correctly indented. Yes, this scenario I think represents the reality of what happens in e-commerce a little bit, no? somebody goes to the main page, then they stop there for a while, in this case 10 seconds. Then they open a product and they stay there for a while, let's say 10 seconds. They go back to the main page, they stay there for a while. Then they go to another product and then they stay there. So basically each of the tests will launch 1, 2, 3, 4, 5, 6 requests. So this is getting a little bit more out of control. But this is reality. This is how people are interacting with the service. We have still the 60 seconds, 5 requests of these ones. That means 6 requests per second. But this will not finish in 1 minute. And that's the interesting bit of this. This request will take 1, 2, 3, 4, 5, 50 seconds to finish, plus the time that there is. So these tests are going to run for 1 minute, send these 6 requests, and then close. So a lot of requests are going to step over each other. So let's save this. Let's see if this finished running. You can check. Everything looks good, no explosion. We like this. Let's see now if we get to break the system. So we can make sure that this is still refreshing, and we can go and see our dashboard before running anything. There is no errors. The amount of invocations have scaled to stable 900 when we have the 2 minutes stable connections. We have a couple of concurrent invocations. That means that there is multiple Lambda functions running at the same time. So everything looks good. Our latency is very low because everything is very warm. So let's try again. And now I see you when these start testing, because it takes a while, as you know. So now the tests are running and we can start seeing some of the requests. We can see that there are 5 requests per second. This is the first 5 requests that we are sending here in the first minute. Then we can start seeing this spiking, because now every of these calls is a request. So we will see that growing. 12 requests per second, 17 requests per second, and the warm-up ends with 22 requests per second, but everything is being under control. So that's good. Now we have our ramping up, and ramping up will ramp from 5 requests per second to 15 requests per second. Basically, it will run the tests 15 times per second. So we start now seeing that increase, and let's see if we see some errors. So we can see that it's increasing slowly, and things are kind of still working, so we are good. Now we have 47 requests per second, and the ramp up is done. 55 requests per second, and now we are in the sustained load, and this should be pretty stable. 75, 64, 74. So these are going to stay around that number, but we can start seeing a 502. And you might be wondering, why is that? And I already telling you, it's because we ran out of connections with Mongo. So this is just how this works. There is, I think, 100 connections that you can have with Mongo in the free tier, and we might have reached it. So here we can see that we have done a peak in our first cluster, and boom, that starts giving the 502. So I wanted to show you this because I think this is a clear example on serverless applications that are failing, and how load testing might help you. If you run it in your own machine, you give it to your friends, everybody runs this website, says, oh my God, it's so fast, it's so good. And it's true, it's great. But then you have, I don't know how many users we have now, but let's say we have 15 users or more, like every second we have 15 users joining. So there is many users at the same time. In this case, maybe 74 trying to request at the same time, plus the other requests and blah, blah, blah. then our system is starting to break. And this is very easy to fix. Just go to Mongo, increase your cluster, and then you will be fine. The page clusters, this is a free serverless cluster. It has this limitation because it's a testing cluster or for running small things, but you know the limitations, or you can migrate to Dynamo or something like that. That will just you will just get out from the free tier and start paying automatically, so it will not throttle your connections. So I wanted to show you that because we think that serverless scale, and it's true, but we need to understand our limitations. You can start seeing here the errors in the Lambda functions. They are returning this 502, and that's due to the connections. And we can start seeing how many functions we have concurrently. So we have 600 functions at the same time. So this is really draining our connections. So yeah, this is interesting. Interesting to see the amount of invocations we have and how this starting to really get very big, very fast. And yeah, so that's the lesson learned from running this test. So this should have finished, and we can see that there is some error. So still some requests go through, some requests didn't run through, many of them. This is the average request per second. This is the amount of requests that went through. And you can see here that some of them, most of them, has got an error. And yeah, that's it from this demo. I hope this helped you to understand how to think about the load tests, how important they are, and what benefits they bring. As I said, this video is part of a longer series. In the longer series, we build this application, and in every bit of this part, I'm going to explain different parts, like what is the authentication, how the database works, how storage works, and things like that. So if you're interested in particular solutions for building this type of serverless applications, go and check it out. You will learn about the Lambda web adapter and other things. So that's there for you. And with that said, I see you in another episode of FooBar. Ciao, ciao!